Our topic is molecularity of a reaction. इससे पहले हमने order of the reaction discuss किया. Now, what is molecularity of a reaction? The number of the reacting species, जिसमें atoms भी आते हैं, molecules भी आते हैं, ions भी आते हैं, which must collide together simultaneously to bring about the chemical reaction is called the molecularity of the reaction. First we will write the definition of the molecularity of the reaction and then I will explain it. The molecularity of the reaction, the number of the reacting species, atoms, ions or molecules which must collide together simultaneously to bring about the chemical reaction is called molecularity of a reaction. In case of simple reactions, molecularity simple reactions को elementary reactions भी कहते हैं. It is the, or molecularity is the sum of the species of different reactants as represented in the balanced chemical equation. Now, what is molecularity of the reaction? तो molecularity of the reaction को हम ऐसे define करते हैं कि the number of the reacting species जो होती है, चाहे वो atoms होंगे, molecules होंगे या ions होंगे, जितने atoms, molecules और ions साइमल्टेनियसली एट द सेम टाइम कोलाइड करेंगे टू ब्रिंग अबाउट, ताकि रिएक्शन कंप्लीट हो। इसको हम उन नंबर ऑफ एटम्स, मॉलिक्यूल्स और आयन्स जो एक ही वक्त कोलाइड होकर रिएक्शन कंप्लीट करते हैं, उनको हम मॉलिक्यूलरिटी ऑफ द रिएक्शन कहते हैं। तो अगर हम दिस मॉलिक्यूलरिटी इज डिफरेंट फॉर डिफरेंट रिएक्शंस, कैन बी डिफाइंड डिफरेंटली इन डिफरेंट रिएक्शंस। अगर हम सिंपल रिएक्शंस ले लेंगे और एलिमेंट्री रिएक्शंस जिनको भी हम कहते हैं, तो एलिमेंट्री रिएक्शंस में मॉलिक्यूलरिटी जो है दैट इज द सम ऑफ द रिएक्टिंग स्पीशीज। मजमा, रिएक्टिंग स्पीशीज का मजमा। रिएक्टिंग स्पीशीज मीन्स एटम्स, मॉलिक्यूल्स और आयन्स जो रिएक्ट होके प्रोडक्ट बनाते हैं, तो उनका सम जो है दैट गिव अस द मॉलिक्यूलरिटी ऑफ द रिएक्शन। लेकिन अगर हम इसको बैलेंस्ड केमिकल इक्वेशन में ले लीजिए, एंड इन केस ऑफ द कॉम्प्लेक्स रिएक्शंस, पहले हम इन सिंपल रिएक्शंस को हम, a reaction is said to be unimolecular if only one reacting molecule is involved in the reaction. A reaction is said to be unimolecular if only one molecule is involved in the reaction. For example, तो ये यूनिमॉलिक्यूलर रिएक्शन होगी अगर एक ही रिएक्टिंग मॉलिक्यूल होगा। फॉर एग्जांपल, डिकम्पोजिशन ऑफ H2O2. H2O2 when decomposes it forms H2O plus 1/2 of O2. So only one molecule is involved in the reaction. The molecularity of the reaction is 1. Similarly, a reaction is said to be bimolecular if two molecules are involved in the reaction. अगर एक रिएक्शन में दो रिएक्टिंग मॉलिक्यूल्स होंगे, फॉर एग्जांपल डिसोसिएशन ऑफ हाइड्रोजन आयोडाइड, तो HI on dissociation forms H2 plus I2. So two molecules are involved in the reaction. The molecularity of the reaction is 2. क्योंकि अगर नाउ उस रिएक्शन को जिसमें सिर्फ एक रिएक्टिंग स्पीशीज होगी या मॉलिक्यूल होगा दैट डिकम्पोज एंड फॉर्म्स द प्रोडक्ट, उस रिएक्शन की मॉलिक्यूलरिटी 1 होगी, क्योंकि इसमें हाउ मेनी H2O2 डिकम्पोज टू फॉर्म H2O plus O2, दैट इज 1. सो द मॉलिक्यूलरिटी ऑफ द रिएक्शन इज 1. सिमिलरली a reaction is said to be bimolecular. एक रिएक्शन को हम बाइमॉलिक्यूलर कह सकते हैं if two molecules are involved in the reaction. For example, hydrogen iodide, it deficits into hydrogen and the iodine. Two molecules of the hydrogen are involved in the dissociation to form H2 molecule and I2. So the molecularity of the reaction is 2. Similarly, reaction is said to be termomolecular if three molecules are involved in the reaction. A reaction is said to be termomolecular if three molecules are involved in the reaction. For example, a reaction between NO and O2 to form NO2. NO plus O2 combine and form NO2. Two molecules of NO and one molecule of O2 combine and form twice NO2. So, how many reacting species are involved in the reaction? That is 2 plus 1, 3. Therefore, the reaction is said to be termomolecular, or molecularity of the reaction is 3. Now, in case of complex reactions, now what are complex reactions? Reactions involving a number of atoms, molecules, or ions. Simultaneous collision of the reacting species is very रेयर. तो वो रिएक्शंस जिनको हम कॉम्प्लेक्स रिएक्शंस कहते हैं, तो कॉम्प्लेक्स रिएक्शंस कौन सी रिएक्शंस होगी? वो रिएक्शंस जिसमें that do not take place in the one step, जिसमें नंबर ऑफ एटम्स, मॉलिक्यूल्स और आयन्स रिएक्ट करके रिएक्शन कंप्लीट करके प्रोडक्ट बनाते हैं. तो उन रिएक्शंस को मैं हम simultaneous collision of the reacting species is very rare, बहुत ही कम होता है. And molecularity number of the reacting species is very rare. Molecularity of the such reactions is the first, these reactions take place in a number of steps. These are reactions take place in a number of steps, and molecularity of such reactions is the number of atoms, molecules, or ions which take place in silo step, i.e. silo step is the rate determining step. तो वो रिएक्शंस जिनको हम कॉम्प्लेक्स रिएक्शंस कहते हैं, जिनमें नंबर ऑफ द एटम्स, आयन्स और मॉलिक्यूल्स इन्वॉल्व होते हैं, तो उन रिएक्शनों में साइमल्टेनियस कोलिजन ऑफ द रिएक्टिंग स्पीशीज इम्पॉसिबल है। तो ऐसी रिएक्शंस नंबर ऑफ स्टेप्स में कंप्लीट होती है। तो वो स्टेप जो सिल्वेस्ट स्टेप होगा रिएक्शन का, दैट डिटरमाइंस द मॉलिक्युलरिटी ऑफ द रिएक्शन। फॉर एग्जांपल, decomposition of nitrogen pentoxide. E.g., decomposition of N2O5. When N2O5 decomposes, that is the thermal decomposition of the nitrogen pentoxide, it forms twice NO2 plus O2. This is 4 times. So according to the rate law, rate of this reaction is equal to K N2O5 raised power 1. Here the two molecules of the nitrogen pentoxide decompose to form the nitrogen dioxide and the oxygen. But experimentally it has been observed that the order of the reaction is 1. Here the coefficient of N2O5 is A, where the power of N2O5 on which the rate depends is 1. So alpha is 1, the order of the reaction is 1. This reaction then must take place in a number of steps, e.g. N2O5 first decomposes, forms NO2 plus NO3. This is single step, and N2O5 then again reacts with the nitrogen pentoxide, forms thrice NO2 plus O2. तो पहले स्टेप में एक नाइट्रोजन डाइऑक्साइड और नाइट्रोजन पेंटऑक्साइड बनता है। तो नाइट्रोजन पेंटऑक्साइड जो है, ट्राइऑक्साइड जो है, नाइट्रोजन पेंटऑक्साइड decomposes form nitrogen dioxide and nitrogen trioxide. This is a very slow step, and the nitrogen trioxide immediately reacts the left out nitrogen pentoxide and forms nitrogen dioxide and oxygen. So in the final product, we don't have nitrogen trioxide. This nitrogen trioxide is called then the intermediate. The first step is the single step and the second step is the first step. In the first step, it is the number of nitrogen pentoxide which decompose, that is 1. Therefore, the molecularity of the reaction is 1. So, in case of the complex reactions, it is not the overall molecularity of the reaction which matters, it is the molecularity of the reaction involved in the simplest step that determines the molecularity of the overall reaction. So, dear students, this was all about the molecularity of the reaction. Now, characteristics of molecularity. These are, number one, the molecularity of a reaction can only be a simple whole number positive integer. That means it can have values 1, 2, 3, etc. The molecularity of reaction cannot be fractional or it cannot have value 0. Number third, the molecularity of a reaction is not same, cannot be the same as the order of the reaction except in case of the elementary reactions where the molecularity of the reaction and the order of the reaction is same. So these were the three important characteristics of the molecularity of the reaction. Now we will discuss the how we can differentiate the molecularity of the reaction with the order of the reaction. That too is important and is frequently asked in the examination. Difference between the order of the reaction and the molecularity of the reaction. Now, difference between the molecularity and the order of the reaction. This is order of the reaction, and on the right side of this we will write the molecularity of the reaction. Order of reaction is the sum of the powers of the concentration terms in the rate law expression. तो जब हम rate law expression लिखते हैं तो rate law expression में जो sum of the powers of the reacting species जो होता है that determines the order of the reaction. Whereas in case of the molecularity of the reaction, the molecularity of the reaction in case of the simple reactions or the elementary reactions is the number of the reacting species that collide to bring about the reaction, or it is the number of the reacting species present in the balanced chemical reaction. The molecularity of the reaction is the number of the reacting species undergoing simultaneous collision in the elementary reaction. Number second, the order of the reaction is determined experimentally and cannot be calculated. Cannot be calculated means it is the order of the reaction is determined experimentally, as we have discussed it. We derive the rate law expression and determine the order of the reaction. So this is the experimental observed value, that is order of the reaction. Whereas the molecularity of the reaction is the theoretical concept. It can be calculated by adding the reactants in the slivous step. In case of the complex reactions, the molecularity of the reaction is the number of the atoms, molecules or ions that are involved in the slivous step, and in case of the simple reactions, it is the number of atoms, ions or molecules that undergo simultaneous collision to bring about the chemical reaction. of the reaction need not be a whole number. It can have fractional value. As we have already discussed, the order of the reaction, a reaction can be of zero order, first order, second order, third order, or even fractional order, just like the decomposition of the acetaldehyde. Or when we combine carbon monoxide and the chlorine, the order of the reaction is fractional. When we combine hydrogen and the bromine, the order of the reaction is fractional. So the order of reaction can be zero, just like we have the thermal decomposition of the ammonia. Or we have photochemical reaction between the hydrogen and the chlorine that take place in presence of the sunlight. All these are the examples of the zero order reaction. So the order of the reaction can be 0, order of the reaction can be 1, it can be 2, it can be 3, or it can have fractional value. Whereas molecularity have only the small integral values, that is 1, 2, 3. The molecularity of the reaction can only be, it can be 1, it can be 2, it can be 3. These are only the integral values. It cannot have the zero reaction cannot have zero molecularity. It cannot have fractional molecularity. Order of the reaction can be 0. As again in the example, we have the zero order reaction. जो अभी मैंने बताया कि we have the photochemical reaction between the hydrogen and the chlorine that takes place in presence of the sunlight, where H nu, when it falls on the hydrogen and the chlorine, the reaction takes place very rapidly and form the hydrogen chloride. And also for other example is thermal decomposition of the ammonia. Whereas the molecularity of the reaction cannot be, this is the order of the reaction, whereas the molecularity of the reaction cannot be 0. The molecularity can have the integral values 1, 2, 3. So these were some of the important points of the difference between the order of the reaction and the molecularity of the reaction. So after completing this order of the reaction and molecularity of the reaction, our next topic will be the integral rate expression, very important for the zero order and the first order reactions. तो आज के लिए बस इतना.